Hello lovelies, in this video the brilliant Mr. B is going to be looking at probability for your GCSE maths. Now there are lots of questions here at 3 different levels and you can use the timestamps to jump in where you feel most comfortable. You can start off with the medium questions, and if they're too hard, go back to the easy questions. There is nobody sitting next to you judging you, nobody at the front of the classroom rushing you. If you're finding the questions really easy, then move on to the harder ones. You don't have to do them all. You can look at the question, pause it, try and answer it yourself, and then play the video to see if you've got it correct. Once you've done that, over on my website there are loads of practice and predicted papers to help you revise.
Have a look at probability, and the first question sums it all up. What number must all probabilities add up to? All probabilities add up to 100%. So if you think about things you can apply a probability to, let's say the weather, all the different combinations of weather events have to add up to 100%. So you could have sunshine, you could have clouds, you could have rain. You could have a mix of cloud and rain. You have more extreme things like snow or lightning. All of those things have to add up to 100%. You're saying these are all the possible things that can happen. Now the question doesn't ask you for a percentage, it asks for a number. What number must all probabilities add up to? Well, we think about how you change percentages into decimals. Percent means per 100, divide by 100. 100 divided by 100 is 1. So you can also say that all probabilities add up to 1, either written as decimals or a fraction, or they have to add up to 100% if they're written as percentages. And you'll see probabilities written as fractions, percentages, and decimals. Moving on to question 2, it says a coin is thrown into the air. What's the probability of it landing on heads? So with probability, identify all the possible things that can happen. You throw a coin into the air, it can land on heads, or it can land on tails. Now, like we said in question 1, probabilities have to add up to 100%. And with a coin, it's got an equal chance of landing on heads or tails. So you can say that it's got a 50% chance of landing on heads, and it's got a 50% chance of landing on tails, and together heads plus tails equals 100%. So for our final answer, what's the probability of landing on heads? We can say 50%. You could write a decimal, you could say that's 0.5, or, and this is really important, you can write it as a fraction. As a fraction, there's 2 possible things that can happen, heads or tails, and only one of them is what you want, heads. 1 chance of heads over 2 possible things altogether. And that, a half, makes 0.5 as a decimal, so that all lines up. All 3 alternatives mean the same thing. But you might be able to see that writing as a fraction is actually a little bit easier because it directly relates to what you've calculated. The 1 over 2, one way to get a tails, one way to get a heads, and it's over 2 because you get your heads and tails alternatives. So, question 3. If the chance of landing on a 4 on a 6-sided dice is 1/6, is the dice biased or fair? So let's identify what can happen. A 6-sided dice, we can get a 1, a 2, a 3, a 4, a 5, or a 6. So what's the probability of getting a 4? So the probability of getting a 4, note how I've written that. P4 is probability of getting a 4. There's only one way to get a 4. It lands on 4. Dice that aren't normal might have more than one face that has the same number, for example. But there's only one way on a normal dice of getting a 4. How many different things can happen? 6 different things can happen. The probability of getting a 4 on a normal dice should be 1 over 6. So if we're being told that a random dice has a 1/6 chance of getting a 4, it is probably going to be a fair dice. If the chance of getting a 4 wasn't 1/6, a few different things could be happening. One thing could be that more than one side could have a 4 on it. That would increase the chance. Alternatively, the dice could have a weight in on one of the faces, and then that could bias it towards one of the different sides. So when we're saying biased, what we mean is it's getting more or less of a fair chance on one of the alternatives. And before we move on, a really important thing with probability is to take the questions at face value. Just take it as the most boring explanation of the question. Don't try and think of all kinds of weird things that could possibly happen. Just make it straightforward as possible. So when we're talking about dice rolls, it's a 6-sided dice. It hasn't told explicitly that it's a dice with 1, 2, 3, 4, 5 and 6 on it. But you just assume it's a basic, boring dice with those things on. When you're flipping a coin, again, the most boring explanation possible. It can land on heads or it lands on tails. A lot of students will say to me things like, oh, it could land on the edge, and that could be a probability. It's like, not really, no, it's very, very, very small chance. For the purpose of these questions, treat it boring, straightforward. Coins are not going to land on the edge. Don't try and find little exceptions and things like that. And then that's relevant to question 4. A deck has 52 cards. When we talk about a 52 card deck, there is a standard card set that is used around the world that we are talking about. A 52 card deck, it has 4 suits. So each card can have one of 4 different symbols on it. It can have a heart, it can have a diamond, and these are always coloured in red. I'm using pink, that's the closest pen colour I've got. And you could have a spade. Now a spade, it's pointy, and it's kind of got a curve on the bottom like this, with a little bit sticking out. Now, spades are always black. I'll use dark purple, that's the closest I've got. And the club, it's got the same little bottom that the spade has got, but rather than going to a point, it's kind of 1, 2, 3 kind of circles, kind of like almost part of a 4-leaf clover. Now, it's assumed that you know this because not too long ago, these are really common things that everyone played with. And when I was brought up, my granddad played with these with me. I was very familiar with the 52 deck of cards. In the last kind of 10, 20 years, with technology, a lot more people now are using kind of electronic entertainment, and this is kind of falling away a little bit. So you do get a lot of students who haven't actually used 52 card decks before. So do try to familiarise yourself with it, because it might come up in exams. Now, as well as each card having a heart, a diamond, a spade, or a club on it, they have something else as well. They have a number. And the possible numbers that can be on the cards are ace, which usually stands in for a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have jack, which normally stands in for 11, queen, which stands in for 12, and king, which stands in for 13. And some card games might have 14, which would be ace again, but there wouldn't be an extra card in there just wouldn't be a 1 in those games. So it's going to have a symbol, and it's going to have a number. So you can have a ace of hearts, a 2 of hearts, a 3 of hearts, 4 of hearts, 5 of hearts, 6 of hearts, 7, 8, 9, 10 of hearts, jack of hearts, queen of hearts, and king of hearts. So how many heart cards are there altogether? When you count up all those numbers, there are 13 numbers. So you can have 13 heart cards, 13 diamond cards with the same pattern, ace of diamonds, 2 of diamonds, 3 of diamonds, and so on, 13 spades, and 13 clubs. So moving on to question 4, in a deck of 52 cards, what is the probability of getting an ace? So PA would represent probability of an ace. You could have an ace of hearts, an ace of spades, an ace of diamonds, or an ace of clubs. There are 4 different ways to get an ace. 4 different cards have an A printed on them. And how many cards are altogether? 52. So the probability of an ace is 4 out of 52. Now, you might have noticed with fractions, where both even numbers, you can simplify that fraction. So you can divide the top and the bottom by 4, or 2 twice, a few ways of doing it. And you can simplify that to 1 over 13. So which one is the correct answer? Well, usually in probability, you do not need to simplify, because 4 out of 52 gives you extra information. There's 4 ways to get an ace. There are 52 cards in the deck. When you simplify it to 1 over 13, you've lost that information. You could maybe say that there's 1 chance of getting an ace in a suit of cards that's got 13 different symbols, but like I was saying before, you want to keep this as straightforward as possible. So 1 out of 13 is not a wrong answer, but you don't usually need to simplify. Although sometimes the question might ask you to, so just watch out, read through the question carefully. Has he asked me to simplify? Let's look at the last question. A deck of 52 cards is shuffled and placed face down on a table. What is the probability of picking up a card with spades on it? So we want the probability of getting a spade. So we'll draw a little spade symbol best I can. And how many spade cards are there? Well, we have the ace, the 2, 3, 4, 5, 6, 7, 8, 9, 10, the jack, the queen, the king. That's 13 different cards with spades on them out of 52 cards total. And again, you can simplify this. You can divide the top and the bottom by 13 and get 1/4. And the quarter represents that there's one spade suit out of 4 different suits. But again, we've lost the information that there's 13 cards in the spades and there's 52 altogether. So simplifying to 1/4 isn't necessary. One last thing, keep things as simple as possible. If you are familiar with these decks of cards, they may have a joker card in, which is used for some games. And the joker card doesn't usually have a suit. It doesn't have a number on it, just says joker. They also have things like rule cards. Some decks of cards will come with a little card that says, here's how you play bridge. Here's how you play poker. We're not including those cards, again, keeping it as simple as possible. Your 52 card deck does not include a joker. It does not include spare cards or rule cards. Keep it nice and simple. Unless it explicitly tells you this deck has got 1, 2, 3 jokers in, then you can include them. Now moving on to the reading questions, things start to get a little bit wordy, a little bit more complicated. This is really common with probability questions. Just going through the highlighters, picking out all the numbers. For question 1, we have 30 girls, so pick the word that goes with the number. And it says that 10 like dogs. And these are the only numbers we have in the question. So let's read the question. What is the probability of picking a girl who doesn't like dogs? So, the probability of picking a girl who likes dogs, so a little tick and a D to show P tick D, probability liking dogs. So I'm just going to tick at random, it's not a mathematical symbol, and D for dog. So write whatever in the brackets you want. You could write like dogs in the brackets as well, be a bit more thorough. The probability of picking a girl who likes dogs, there's 10 different girls who like dogs, and 30 altogether. Now, I'm not being asked that, we're being asked the probability of a girl who doesn't like dogs. So what do we do? So, probability, and do a cross with a D for not liking dogs. Well, if 10 like dogs, you've got 30 altogether. There's 20 other girls who haven't said they like dogs. So if we assume they don't like dogs, that would be 20 over 30. A really important thing to note here is what happens when we add those together. 10 over 30 plus 20 over 30 gives you 30 over 30. And 30 divided by 30 is 1. So we're coming back to that fact that probabilities have to add up to 1. If 10 like dogs, then 20 must be doing something else, and it has to add up to the total 30. And again, now we're keeping this as simple and straightforward as possible. We're not saying, whoops, maybe some of those girls are indifferent to dogs, maybe some don't know what dogs are. You can come up with all kinds of different scenarios here. Keep it really simple. Like dogs, don't like dogs. Moving on to question 2, let's look at the numbers. We have 15 balls, and 7 are green, 5 are black, 3 are orange. So we've identified the numbers. Now let's look at the question. It says, what is the probability of picking an orange ball? So PO for probability of orange. So probabilities, we always have the total in our fraction. The total is the denominator of the fraction. There are 15 different balls we can choose. It's out of 15. We want the probability of orange. How many orange? 3 are orange. The answer is 3 out of 15. Moving on to question 3. So first thing to do, try and find the total. We have 20 counters. Once you find the total, find all the rest of the numbers. We have 9 white counters. We have 5 green counters. And we have 6 brown counters. We're being asked, what is the probability of picking a brown counter? So then look at the total. It's out of 20. The denominator is 20. The bottom number is the total. Then for the numerator, the top number, we're looking for what we specifically want. We want the probability of picking a brown counter. There are 6 brown counters. Question 4. Look for the total. We have 21 sweets in a bag. Once you find the total, find the categories it's broken down into. We have 4 chocolate, we have 8 toffee, and then the rest are caramel. So we don't actually have a number for caramel. We want the probability, though, of getting a caramel sweet. So how do we do that? Well, then remember, probabilities have to add up to 1. So if the probability of getting a caramel, if the denominator must be 21, because that's how many bags are in, how many sweets are in the bag, then have a look at the numbers we've got. We've got the 4 chocolate and the 8 toffee. That's 12 sweets accounted for. So what we can write here is the probability of not getting caramel is 12 over 21. And you'll see a little dash next to the P. That dash just means not. The probability of not getting caramel. So the probability of getting caramel must be the number that adds on to 12 to get you to 21, to get you to the total. And you can add 9 onto 12 to get 21. And so the probability of picking caramel and not picking caramel adds up to 21 over 21 and adds up to a whole one. Now looking at the last medium question, for a total there are 50 shapes in a bag. Let's break that down. We have 34 hexagons, 6 are triangles, and then the rest are quadrilaterals. So we don't have a number for it. And surprise, surprise, we're being asked what's the probability of picking a quadrilateral, the number we've not been given. So we need to find first the probability of not picking a quadrilateral. So we have our 34 hexagons out of 50 overall. We have our 6 triangles, over 50 overall. Add those up, that's 40 out of 50. So you'll notice in question 4, I did the 4 plus 8 in my head and used mental arithmetic, that's fine. It's a bit more complicated, you can write it like I've just done and add the fractions together. So the probability of not getting a quadrilateral is 40 out of 50. That means there are 10 shapes left over that must be represented in quadrilaterals. 10 over 50. Just double check, 40 over 50 plus 10 over 50 gives you 50 out of 50. That's a whole one. Moving on to the hard questions, and now there's more text again, more complicated, and we have mixed units. So for example, in the first question, I can see that I've got a percentage, probability of getting black was 32%. We also have a decimal. The probability of red is 0.11. So we have a mix between percentages and decimals. What we don't have in the first question is nowhere are we told what the total is. However, we don't know what the total is. The total's always the same for probability. It's 100% is a total. So if you write it as a fraction and you want a denominator, you can't use 100% of the denominator. It's going to be what everything adds up to in the question. But if you're given things in terms of decimals or percentages, your total is going to be 100% or it's going to be 1. So be careful the difference between those two things. So the probability of getting black is 32%. The probability of red is 0.11, and what we need to do at this point is move everything into the same sort of notation, the same sort of units. So 0.11 is 11%. And go and watch the videos on changing between decimals, fractions and percentages if you're not too sure about that. So if we want the probability of getting white, everything needs to add up to 100%. The probability of black and red is going to add up to 43%. So to get 100%, we need another 57% to get there. So the probability of white is 57%. Remember that all probabilities have to add up to the total, 100%, or 1. Moving on to question 2, identify the numbers. Brown eyes is 0.32. And then we have, so it's a girl with brown eyes and a boy with brown eyes. Now I'm not given a number for this, but it's double the girls. So double 0.32 would be 0.64. So now we want the probability of picking a boy who doesn't have brown eyes. So if the probability of choosing a girl with brown eyes is 0.32, and the probability of picking a boy with brown eyes is 0.64, then the probability of everything else, probability of the rest, so that could be blue eyes, green eyes, hazel, anything in between, and for boys and girls, it all needs to add up to the total. It's going to add up to 1. So 32 plus 64 is going to give us 96. That leaves us with 0.04 left over for the rest. They all add up to 1. If that confuses you, think about percentages. That'd be 32%, 64%, and 4%, adding up to 100%. Now the question says, what's the probability of picking a boy who doesn't have brown eyes? Unfortunately, given the information we have in the question, we can't answer that, because while it's contained in that 0.04, it's within that 4%. We don't know how many girls don't have brown eyes, so we can't separate those two things with the information we have, so I have to leave it there. If we were asked to explain our answer, then maybe we get an extra mark for saying we can't get this answer for these reasons. Question 3, a class contains 20 boys and 10 girls. So our total is 30. And then for the rest of the numbers, the information from the question, a fifth of the girls have a cat. 3/4 of the boys have a cat. So the probability of a girl who has a cat is going to be a fifth of the girls. So it's going to be a fifth of 10. Now a fifth means divided by 5. So 10 divided by 5 is 2. And the final question says, what's the probability of being a student that doesn't own a cat? So we'll put that over the total of the students, 30. 2 girls have a cat out of 30 students total. The probability of a boy having a cat is 3/4. That's going to be divided by 4 and multiplied by 3. So 20 boys divided by 4 will give us 5, multiplied by 3 gives us 15. And 15 out of 20, that's 3/4, it's 75% of 20. There's a few different ways of working it out. But again, I'm not going to write it out of 20, the total for the boys. I write it out of 30, the total for all the students. The probability of picking a boy who likes cats or has a cat is 15 out of 30. So what's the probability of picking a student that doesn't own a cat? So it says student, it doesn't specify gender like the last question, so we're going to add these together. And that gives us 15, and that gives us 17 out of 30. The probability of a student with a cat is 17 out of 30. So what the probability of them not having a cat, it has to add up to the total. So 17 plus, we have to add 13 onto that to get to 30. So 13 of the students, boys and girls, out of the 30 students, don't have a cat. Now I just want to highlight the different answers we've had here. I'm going to highlight them in a different colour. So let's highlight them in purple. So for question 1, the answer was 57%. In question 2, the answer was 0.04. And in question 3, the answer is 13 out of 30. So just look at the 3 different ways you can write your answers. Question 1, the question is mostly in percentages. I've written my answer as a percentage. The total for percentages is 100%. We have to add up to 100%. Question 2 is mostly written in decimals. And in decimals, everything has to add up to 1. And in question 3, the total is given to us as a number. It's 30 students in total. It's mostly written in fractions, so it has to be out of 30. So written as a percentage, it's out of 100, it adds up to 100. Written as a decimal, it's out of 1, it adds up to 1. Written as a fraction, then it's out of whichever number in the question gives you the total, and that can change. In this case, it's 30. So just be aware of the 3 different ways. These are interchangeable. For question 1, you can have written 0.57. For question 2, you can have written 4%. So you can change things around. For question 3 of the fraction, well, you could divide that, do 13 divided by 13, get a decimal, you get quite an awkward answer. So it's usually easiest to leave things as fractions. Moving on to question 4, so let's look for total. So we have 10 boys like dogs, a third of the girls like dogs, 15 people like dogs, there's an equal number of girls and boys. Okay, so we don't have a straightforward total there. It's quite a complicated question. Let's pick out the numbers we have. So, 10 of the boys like dogs. A third of the girls like dogs. 15 people like dogs. And I'm going to stop there because I spotted something. 10 of the boys like dogs and 15 people like dogs. So there must be 5 girls who like dogs. I'm just trying to find connections between the numbers if it's not a straightforward question. What else do we have? There's an equal number of boys and girls. Are we told how many boys there are or how many girls there are? Well, again, trying to draw a connection here. We're told that a third of the girls like dogs, and we know that 5 girls like dogs. So 5 is a third of the girls. So 3 lots of those, 3/3, would be 15 girls in total. And if there's an equal number of boys and girls, there must be 15 boys total. So that must mean there are 30 students total. And it's really difficult to teach logic things like that, so just look at all the information you've got, keep looking at it, keep kind of pairing up the different combinations of 2 facts, and eventually 2 of the facts will pair together to give you an unknown third fact that you can write down. So the final question is, what is the probability of picking a student who doesn't like dogs? We're not told anything about people who don't like dogs, but we are told about people who do like dogs. So the probability of liking dogs is going to be out of 30 because there's 30 students altogether. 10 boys like dogs and 5 girls like dogs. That's 15 out of 30. So the probability of not liking dogs is going to add up to the total 30. So 15 plus 15 is 30. So the answer must be 15 out of 30. And there's quite a bit of working out there, so let's highlight the answer. 15 out of 30. Now we could simplify that and say, well, let's divide it through by 15 and we get a half. A half the people don't like dogs. That's fine, it's not a wrong answer, but if you simplified it, like I said before, you're losing information. We don't know that 15 people like dogs, we don't know there's 30 altogether, so it's better to keep it as 15 out of 30 than to simplify, just for the case of probability. Let's look at the final question. A bag contains 63 sweets, that sounds like a total. Which clues do we have? Okay, there's X amount of strawberry, we're not being told about strawberry. There are twice as many raspberries as strawberries. Well, if strawberry is X, then raspberries must be 2X because it's twice as much. Then there are 3 times as many lemons as raspberries. So 3 times as many lemons than raspberries. Do we have a number for raspberries? Well, we do. We wrote down 2X for raspberries. So 3 times 2X would be 6X. So if 2X is raspberries, 6X would be lemons. And then strawberries was just 1X. So let's go through that one more time. So X represents strawberries. There's twice as many raspberries than strawberries, so you double X to get 2X for raspberries. And there's 3 times as many lemons than raspberries, so you multiply the raspberries by 3. 2X times 3 is 6X for lemons. So now you can express the total as algebra. The total is 2X plus 6X plus 1X, which is 9X. And we know what the total is. The total was 63. We were told that. So for this probability question, we have an equation. 9x is equal to 63. So let's divide both sides by 9 to get 1x. 9x divided by 9 is 1x. 63 divided by 9 is 7. So x is equal to 7. So that means there are 7 strawberries. There are 2 lots of 7, 14 raspberries. There are 6 lots of 7, 6 times 7 lemons. And we ask, what is the probability of picking a lemon? So it's 8 of 63, lemon is 6x, 1x is 7, so we're going to do 6 lots of 7, which is 42. There is a 42 out of 63 chance of picking a lemon. So the hardest probability questions will use algebra like this one. And finally, to be consistent, let's highlight the same colour as the other answers.